developers moving towards powertrain configurations, where the motor is mounted inside the wheel. That's an in-wheel motor system. We must admit, there is an impressive amount of new space available when the electric motors are integrated into the wheels. And sure, these so-called hub motors or in-wheel motors come with certain benefits, but they also create some challenges. In-wheel motors aren't new. At the beginning of the 20th century, Ferdinand Porsche's first hybrid vehicle used hub-mounted electric motors in each wheel. These motors power the wheel directly. There's no need for a gearbox or drive shaft. When using a reduction gearbox, the speed is reduced and the torque is multiplied. But with an in-wheel motor, there is no reduction. Wheel speed is equal to motor speed, so the required torque and power need to be delivered in a direct drive mode. In-wheel motors are directly exposed to dust, salt, water, and other fluids, but also to vibrations and shocks, which shortens their life expectancy. That's one of the main reasons Ford eventually decided to ditch the in-wheel motor concepts that they were working on for the new electric F-150 in 2008. The four-in-wheel motors, also known as quad motor drive. These four motors deliver instant power and independently adjust torque at each wheel for precise traction control in all conditions. Controlling power at the individual wheel enables torque vectoring.
The hardware will consist of a model around 2 kg in weight. The vehicle is operating on a 3DOF operations. The vehicle model will consist of a RISC-based microcontroller acting as the vehicle's ECU. The ECU would be simple and take input through RF signals passed through a Bluetooth transceiver. The range set for it is 5 to 8 meters. A simple dipole antenna is fixed to it, which will transmit the signal through an HC05 Bluetooth module. Then the next block to which it is connected is the motor driver, used LM293D. The LM293 pairs with two motors, each that give a paired system. The paired system gets to a current sensor that directly monitors the signals going to the motor. As a result, constant monitoring is assisted. A motor failure's basic cause makes it act like a shortcut or open circuit. In both cases, we can simply observe the abnormalities through the sensors. When any discrepancy is detected, an electromagnetic switch will automatically trigger, disconnecting the motor's power supply to stop further damage. This also prevents the wastage of power. The speed drops because the vehicle may stop with a jerk. So to prevent this mishap, the ECU automatically calibrates the torque of the remaining motors to compensate for the speed and prevent sudden stops, which can cause catastrophic failure. Pulse width modulation is the basic approach often used to control the speed of a DC motor. A DC motor speed can be easily controlled with PWM for a microcontroller arrangement. The amount of PWM is increased to the remaining healthy motors to restore the original speed.